Yes, no, maybe. No?
Yes.
Okay, what about Justine and Zeba? Can you see my screen, guys?
Yes, ma'am.
Yes, ma'am.
Okay, okay. Okay. So, yesterday itself, we started with the states of matter, right? So, we'll just quickly give it a recap. What are states of matter? So, basically, we did that there are three states of matter. One is solid, other one is liquid, and third one is gas. Okay. So, what is solid, ma'am? Basically, solid have definite shape, like the fixed shape, the fixed boundaries, the fixed volume, and their negligible compressibility. Compressibility means that you cannot compress it. You cannot change their shape by compressing it, right? But, and plus we did one more characteristic that solid have tendency that they maintain their shape when subjected to outside force. Okay, so these were the characteristics of solid. But the question was that, ma'am, if rubber, you told us that, ma'am, you cannot change the shape of solid. But how can, when we stretch a rubber band, then for example, you are stretching it, it will be something like that. So how can you say that rubber is a solid? Because you told us that solid don't change their shape. So how can rubber is changing their shape? So basically, why rubber is changing their shape? The rubber will basically regain the same shape once the force is being released. For example, you applied force, the shape became like this. But once you will exert the force, or you will just leave the force, then it will again regain the same shape. Clear? Next, the question was, ma'am, what about sugar and salt? Like, how can you say that sugar and salt are basically, for example, you are keeping them in this jar, then the shape of the sugar and salt particles will be like this. If you keep them in this, then the shape will be like this. So how can you say that solid particles or the solid material don't change their shape? So basically, what happens, we are not talking about the entire things. The shape and of each individual sugar and the crystal remain fixed. And whether you are going to take it, for example, the particle of sugar is like this. If the shape is like this, so whether you are keeping them in your hand or in a table, wherever you are putting it, right? So that is going to be basically, what is going to be, they are going to be of same shape. Okay, so that's why you can say that yeah, solid don't change their shape. Okay, now the best example, but the best question is, what about sponge, ma'am? You told us that sponge is a solid material, but when we compress the sponge, it's shape the same. So how can it be possible? So basically, what happens? Wait, a sponge has minute holes in which air is trapped. So basically, if this is a sponge, it has minute holes, and because of this, whenever you press it, the air goes out and it comes down. Okay, or it get compressed. Clear? Yes,
Yes.
guys. Guys,
Yes, ma'am.
I think you today girls are a little bit lazy, or you can say they haven't done lunch yet. You have done your lunch, both the girls.
Yes, ma'am.
Okay, okay. Jeva, you have done. Jeva and
Yes, ma'am.
because today Adil is active. Yes, ma'am. But girls, okay, okay. So now basically, yeah. So now coming to liquid part, we discussed that liquid, they don't have any fixed shape, but they have fixed volume. Okay, and they can take up the shape of the container, right? And liquid flow, they change shape and they are not rigid. That's why they are known as fluid, because they flow, right? They flow from one place to another. That's why they are fluid. And now the question was that, ma'am, for example, we people are taking oxygen. Okay, but what about the, for example, when we people go for swimming, there if you'll go underwater, you cannot breathe, right? So why, ma'am? But the organism who are living inside the water, like fish and all that, how they take oxygen? So basically, they have gills with them, and they take oxygen from the water itself. So water the water in which the fish and all that they live, that water contains dissolved oxygen. So they take oxygen from that water, they take out it through the help of gills, they process it, and that's why they take oxygen. But though we have lungs, we don't have that machine, or you can say the process through which we can take out oxygen from the dissolved water. That's why whenever we go underwater, we cannot breathe. Clear?
Yes, ma'am.
Yes, ma'am.
So now the other question was, for example, you are mixing liquid and liquid, and you are mixing liquid and solid. So which one will be more faster? Which diffusion will be faster in which one? Liquid or liquid or solid? Adil will tell.
Liquid and liquid.
Yes. So basically, it will be more in liquid and liquid. So why? Because the rate of diffusion of liquid is higher than that of solid. Why so? Because for example, this is liquid and this is solid. So particles over here are closely paired like this. But in liquid, they are like this. So they can easily get intermixed. Right, but here they don't have space, so how they will intermix? That's why diffusion rate is slower in solids and it is higher in liquids. Okay, then we did about gaseous state, that it has no fixed shape, no fixed volume, nothing. But one thing which is very important is they have high compressibility. You can compress the gas, okay, in a very good manner, or you can say large amount of gas can be compressed in small cylinder. Okay, so basically example of compression we can use, first one is LPG, right, and second one is CNG. So Adil, no, yeah, Jeba was there in the class. So Jeba will tell me why we use LPG in for cooking food.
Yes, ma'am. Uh, as we use CNG as fuel, due to its high compressibility, large volume of a gas can be compressed into small cylinder and transport easily.
Okay, good. Okay, so that's why we use LPG and CNG, both of them, because for example, you are cooking something, right? You need good amount of energy, right, or good amount of fuel. So it is not possible for you to refill your cylinder on the daily basis, right? So that's why you use LPG in your gas cylinder, so that you can compress large amount of gas in single cylinder, so that you can use that cylinder for entire 1 month, so that you don't have to go every day to refill that cylinder, right? So that's why LPG is being used in the home. Plus CNG is being used, why? Because you can also compress the natural gas. This is also compressed natural gas, and you can easily transport it. You'll just keep it in your car or any vehicle, and you can easily transport it. And that's why you do this. You use CNG and LPG in the form. Clear, guys?
Yes, ma'am.
Yes,
Oh.
yes.
Okay. And the other example which we already did, that in gaseous state, the particles move about randomly at high speed. So in gaseous, you can know, we already did the example of cooked food and all that, right? So basically, it will be the smell of cooked food reaches us in second as compared to the rate of diffusion of solid and liquid. So basically, one reason was that whenever temperature increases, kinetic energy increases and speed of particles increases. Second is in gaseous state, rate of diffusion is highest. So uh, gaseous state rate of diffusion is higher. That's why also you get the smell of the food, whether you are in other room or other to other room. Okay, I hope it's clear now,
Yes, ma'am.
right? Okay. Now basically, uh, okay. Before that, we will let's just do a few questions. Okay. So who is going to tell me the first one? Just read the question and tell me the first one. Okay, the question is, the mass per unit volume of the substance is called density, and density is mass upon volume. Okay, so now you are going to arrange the following in increasing density. Okay, so increasing density means first one will be something which you have highest one and the lowest one. So everyone will just give it a try. Everyone will write their answer in chat box. Density means mass upon volume. So basically, you can just compare the weight. Okay. So you have to write it down. First you will write like this. You will write first, second, like this. So first one will be who has highest mass, and like this, slow, slow, slow. Done. Okay, got the answer. Here is also okay. What about girls? Okay. So yes, the answer is basically you are going to write it. Just don't get confused. I'm just talking about the density. So which one will be the heaviest one? Iron. So it is going to be like this, like air, like increasing order. Okay, because they have asked in increasing order itself, but I asked you about the decreasing order. Okay, so it is something first air, like sorry, iron, and after that, what you can say? Who will tell me? The chalk, right? Clear. Then honey, then water, right? I hope I'm doing fine. Cotton, then chimney one, and the air one. Then you are talking about iron is going to be the heaviest one. So density will be the heaviest one. And after that, the chalk. Okay. And after that, the honey. Because as compared to water and honey has more particles. So honey, it's sticky and all that. Water, then cotton, then chimney paste, and then last air. Okay. Because you cannot, even tell me the weight of the air. Right. So that's why the last one will be the air. Yeah, but as per they told you to arrange in the order of increasing. So basically you will arrange it like this one. Okay. I hope it's clear.
Yes.
Yes,
Okay.
ma'am.
I told you the way the heaviest one will be the iron. So if you arrange them in the increasing one, then the air will be the first. Why? Because air has the least. Then second, the exhaust from chimney. Then third, like this, it will continue. But I told you according to the density that iron is the heaviest one. That is the decrease, highest one. Then after that, chalk, the less highest one. Then honey, water, something like that. I hope it's clear now, the density part. Right? So wherever you are getting density, that means how much weight they possess. Clear?
Yes, ma'am.
Yes, ma'am.
Now comment upon the following. This you already know. Rigidity, compressibility, fluidity, filling of gas container, shape, kinetic energy, and the density. Okay. That one thing which I want to tell you people, the kinetic energy. So who will tell me what is the kinetic? You have to compare them in the three states. Okay. So solid, liquid, and gas. So what about kinetic energy? Kinetic energy will be higher in which? Solid, liquid, or gas? Who will tell me? So basically kinetic energy, see, for example, these are the particles. Okay. So kinetic energy is, these are the particles. They have to roam around. So the particles who are freely moving, they will have more kinetic energy. And the particles who are not moving, they will have less kinetic energy. right? So similarly, in gaseous, it will be the highest, then in liquid, and then in solid. Kinetic energy will, because they are moving freely, because they have lots of intermolecular space. That's why kinetic energy will be highest in gas, then liquid, and then solid. I hope it's clear.
Yes, ma'am.
Yes, ma'am.
Oh. See, students, right now I can understand it's very, sometimes, whenever we do chemistry, it's the terms and all that, they are related. But try to relate it with everything so that you can even answer any question, whatever asked. Okay? And the next one is the gas filled up completely vessel in which it is capped. Okay? So basically, yes, what is the reason for that? That, okay, ma'am, the molecules of gas have high kinetic energy. That's why you're going to keep it. The gas exit pressure on the walls of the container. So yes, ma'am, whenever you are keeping gas, like whenever you are compressing the gas, they exert force on the wall. Okay. Next, a wooden table should be called solid. Yes, ma'am, wooden table should be called solid because it has fixed shape, fixed volume, rigidity. You cannot compress it. That's why you will be saying the wooden table solid. Next, we can easily move our hand in the air, but to do some through the solid block of wood, we need to karate expert. So karate expert, right? So why? Because in the air is a gaseous state, molecules are freely available or they have lots of intermolecular space. But when we'll talk about the solid block, in this they don't have freely moving particles. So they don't have space in between. That's why you cannot easily break that brick or the stone. Clear?
Yes.
Yes, ma'am.
Okay. And next one is liquid generally have lower density as compared to solid, but you must have observed that ice floats on water. Find out why. Very, very important question. Liquids generally have lower density as compared to solid. Okay, but you have seen that, for example, this is water and ice. If you put the ice cube over anything, maybe in cold drink or anything, they'll float, right? So you told us that liquid generally have lower density as compared to solid, but how can you say that ice floats on water? So this is very important. See, ice is solid. Ice is solid, right? Ice is a solid, but its density is lower than water due to its structure. Just remember this line. Ice is solid, okay? But its density is lower than liquid due to its structure. Okay, so why? See, of course, higher density one will not be floating. Its ice is solid, but its density is always lower than liquid due to its structure. Okay, so basically, just remember one thing: the structure ice is made up of. Okay, because of that structure, they have holes in between, right? So that's why it floats over liquid, and liquid don't float over that. Is it fine? So if
yes,
someone will ask you that why, see, of course, higher density one won't be floating, right? So liquid generally have lower density and solids have higher density. So liquid should float now and solids should be downward. So why solids are floating? So because of their structure, they float. Clear?
Yes, ma'am.
Okay.
Yes, ma'am.
Now, can matter change in states? Can matter change in states? So yes, ma'am, matter can change states. Basically, we have three states, right? Solid, liquid, and gas. Okay. So, ma'am, we all know that our observation that water can exist in three states: solid as ice, liquid as water, and gas as water vapor. Okay. So, for example, this was the piece of ice, and this got converted into liquid. Okay. Then, when you heat it, it will change into vapor. So, it was solid, it was liquid, and now it is gas. Okay. So, how it takes place? This is the question. Okay. Okay. So basically what happens on increasing the temperature of solid, the kinetic energy of the particle increases. Due to increase in the kinetic energy, the particles start vibrating with greater speed. The energy supplied by heat overcomes the force of attraction between the particles. The particles leave their fixed position and start moving more freely. Okay. A stage is reached when the solid melts and is converted to the liquid. The minimum temperature at which solid melt to become liquid at the atmospheric pressure is called its melting point. Okay. Oh my God, ma'am, whatever you mentioned, it was something you were reading something, right? Something like that? Nothing to understand? Yes, no, no, no. Just tell me yes, no. I can understand that. Of course, I gave it a reading, so it won't be easy for you to understand. No? Tell me, tell me. What happened? You can say no, ma'am. I can understand that. Adil got it. Like whatever I read, you got it.
No.
Okay. What about Jasleen and Zeba?
Ma'am, I got it what you said.
You got it?
Yes, ma'am.
Okay, that's great. And what about Zeba?
Ma'am, I only told.
Okay, okay. Okay. So basically what I was trying to tell you people, let's see. We have three states. One is solid, one, okay, I'll just use a black marker there. Okay. So what I was telling you, this is solid, this is liquid, and this is gas. Okay. So if you want to, for example, this is ice. Okay. If you want to convert that ice into liquid, you need to melt it, right? Only then it will be converted into liquid. So basically what happens, for example, this is the beaker. Ice cubes are over here. So what you will do, see, right now the temperature is basically, you can say, minus 25 degree, because of course whenever the temperature is in minus, that means it is in frozen state. Okay, so for example, it is in 25 degrees Celsius. Let's just assume minus 25 degree. Okay, now you want to convert solid into liquid. Okay, so this ice cube, what you will do, you will heat them up. Okay, so you will heat it. If you heat it, then temperature will start increasing. From minus 25, it will go to minus 15. Then from minus 15 to minus 10. And then from minus 5 to minus 5 and then 0 degrees Celsius. Okay. When it will reach 0 degrees Celsius, then your ice will start melting to become liquid. Okay. So basically, if I'll ask you at what temperature ice melts. So, ma'am, ice melting point of ice is basically 0 degree Celsius. Clear?
Yes, ma'am.
Yes,
Yes.
ma'am.
Yes.
Okay. So this is the example you have to remember that, for example, you have a beaker in which ice cube are there. So basically, if you have ice cube, the temperature of ice cube will be in minus degree because they are frozen, right? So now you have to melt, because only when you will be melting it, they'll be get converted into liquid. So you'll start heating them up. 25 to 15, 15 to 10, 10 to 5, and somewhere it will be 0 degree Celsius. But just student, tell me one thing. For example, this is a beaker. You are going to melt this ice cube. So after melting, for example, they are in liquid form. Okay. So the temperature, this liquid is hot or it's cold. This this water is basically the warm. It becomes warm water, or it is like the chilled one. When, if, for example, you have ice cube with you, right, and that ice cube melts. So after that, the water that is on the surface, it becomes cool. It is like it is warm, or you can say it is chilled one.
Cool.
Warm, okay. According to Adil, warm. And what about Jasleen and Zeba?
I said it's cold.
Okay, cold. Okay, okay. So I heard it. Okay, cold. What about Jasleen and Zeba?
Ma'am, it's warm.
Okay, warm. Uh, who gave me the answer, Jasleen or Zeba?
Ma'am, Miss Zeba.
Okay. What about Jasleen?
Warm.
Okay, warm. Okay. So this experiment you people will be doing tomorrow. Okay. Just I hope everyone have refrigerator and they have ice cube in your fridge. Yes.
Yes.
So
Yes.
what you will do, you will just take out the that ice cube and just leave it in a plate. And once they get melt, just touch the water and test the temperature, whether they are warm or whether it is cold. Okay, just do it. Okay, and then you'll get to know. Okay. So basically, what happens, basically, students. So whenever, see, for example, this is your watermelon. Sorry, not watermelon. It's lemon soda maybe. So when you pour your ice cube, so what happens? The temperature increases or decreases?
Decreases.
decreases now. Basically what happens, just to make that water more chilled, you add ice cube. So that means when your ice cube will melt, the temperature will be cool. The water it will be forming, it will be cool. You will do the experiment and you will get an idea. But right now I'm just telling you that whenever ice get melts, it get changed into water. The temperature of water remains same. Whatever the temperature of ice is, the temperature remains same. Okay. And whatever, for example, this ice cube was in this beaker. So you heated it up. So the temperature won't be changing, but the beaker will be becoming hot. Okay, so that's why this is also known as the heat which came. Though you heated it up, but still there was no effect on the ice. So that heat got somewhere, you can say, left out. Okay, and the left out heat or the hidden heat is known as latent heat. Latent word means hidden. Okay, so latent word means hidden. I hope it's clear.
Yes, ma'am.
Yes.
Okay, so tomorrow both Jaslin and Jeba will be doing the experiment and they'll tell me what was the temperature of the ice. Okay.
Okay.
Okay, ma'am.
So now basically, so if you want to convert solid into liquid, you need to melt it, right? And if I'll ask you at what temperature, this ice cube will be melt. So that will be known as melting point. So melting point of ice is, ma'am, at 0 degree, they will be melting. Okay. See, the SI unit of temperature is K, right? So that's why the 0 degree is also, if you, this is Celsius, 0 degree Celsius. And the SI unit is K, which is Kelvin. So you can write 0 degree Celsius or you can write 273.15 K. Clear?
Yes, ma'am.
Okay.
Yes, ma'am.
So basically, what you are going to write now, you will be, okay, I'll just share my screen. I'll just explain you. I hope now it will be clear. Okay. So this is what it was written, that what happens, a stage is being raised, okay, when the solid melt and is converted into liquid. The minimum temperature at which solid melt to become liquid at the atmospheric pressure is called the melting point. Okay, so now how you're going to make your notes? You're going to make your notes like this. Ma'am, solid to liquid. Okay, like this you'll do. First, okay, just give it a heading. A change in state. Change in state, give it a heading. Change in state. Okay, change in state. And after that, because you have to make your notes precisely, that's why I'm just sharing you this notes. And then you'll write this solid to liquid. Okay. If you want to draw this diagram for your better understanding, you can. Because when you will be, revising it, that will be a greater, like you'll get to know like how come 0 degree, why not 15 degree or 10 degree, 5 degree, whatever it is. Okay. If you want to draw it, you can. If no, not a problem. Just write solid to liquid. Okay. And you'll write solid, and below that you'll write ice, and below liquid you'll write water. Okay, you can draw a diagram like this. It will be easy for you. If you want to draw it, it will hardly take 1 minute, so you can draw it. Now, ma'am, what to draw? Basically, you just don't have to draw everything. Just draw this beaker and just write heat. Then just write 25 degree. This, 0 degree. And over here, just write melting point. Okay, melting point. Just write it. Just draw it, and then I'll explain you what you have. Done, students?
Yes.
Okay, girls. Done. You have to draw the diagram. You don't have to write anything. I'll just let you know what you have to write.
Done, ma'am.
Okay. Now, after that, you'll put a point and you'll just mention. Use the black one. That's good. Okay. After that, you'll use the black this point and you'll write melting point. Okay. The melting point, and then from here, when the solid melts and is converted to a liquid. Okay, don't write like this. Just write the minimum temperature at which a solid melts to become liquid at the this is very important, atmospheric pressure. Okay, it is called melting point. Clear?
Yes, ma'am.
Yes, ma'am.
Done, ma'am.
Done, ma'am.
Okay. Adil, done?
Yes.
Adil, you are done?
Yes.
Okay. Now, basically, uh, for example, this was a beaker, right? You were heating it. So these ice cubes, basically, they were not getting affected by this heat. But yes, the beaker, if you will touch that beaker, that will be somewhere heat up, right? So what happens? What happens to the heat? But for example, if you are cooking something, right? Then if you heat that particle, of course, the food will be heated up. But why not this ice cube? Why they don't get any effect? So basically, what happens? The air gets escaped. Okay, or you can say this is something hidden heat is there. Okay, so the beaker absorb all the heat and they didn't let affect the ice cube. So that heat is known as latent heat. Okay, latent heat. Why? How I'm converting it? Basically, I'm converting this ice cube into the molten form, or you can say liquid form, through this latent heat only. Okay, clear?
Yes, ma'am.
Okay. Hmm? It's written over here. See, you can see over here, and just mention one more thing, students. Melting point of ice. Okay, just write it like 23 this or 0 degrees Celsius. Okay. Below the definition, just write it melting point of ice is 0 degrees Celsius. And if you'll if the examiner will ask you in the terms of Celsius, then 0 degrees Celsius. If he'll ask you in terms of Kelvin, K, then 273.15 K. students?
Yes.
Yes, ma'am.
Okay. Okay. Now, basically, the melting point of ice is this. The process of melting, that is change of solid state into liquid state, is known as fusion. Don't worry, we'll just do it. Okay, that is known as fusion. Okay. When solid melts, its temperature remains the same. As I told you, the temperature of ice and the liquid will be same. So where does this heat energy goes? So basically, this energy escapes, or this energy somewhere disappears. Okay. So you must be observed during the experiment of melting that the temperature of the system do not change after the melting point is reached till all the ice melts. This happen even though we continue to heat the beaker. That is, we continue to supply heat. The heat get used up in changing the state by overcoming the force of attraction between the particles, as this heat energy is absorbed by the ice without showing any rise in the temperature. So basically what happens to that heat energy, this heat energy is basically absorbed by the ice and without showing any rise in the temperature. It is considered that it gets hidden into the content of the beaker and is known as latent heat. Okay, so latent word means basically hidden. So basically what happens, what is the amount of heat energy that is required to change 1 kg of solid into liquid at atmospheric pressure at its melting point is known as latent heat of fusion. Okay, so now first thing is, ma'am, what is fusion? Okay, so you will write it down, like just give it a point. Fusion. Okay, so what is fusion? Basically change of solid state into liquid state is known as fusion. Okay, and from there it came latent heat of fusion. So in order to change 1 kg of ice, 1 kg of solid into liquid at the liquid at its melting point, because you have to melt in order to change solid from liquid, that is known as latent heat of fusion. That energy is known as latent heat of fusion. I hope it's clear. So if I'll ask you what is latent heat of fusion, so first you will understand, ma'am, fusion. Okay, so fusion is basically changing from solid states to liquid state. Okay, so what is the required, melting or boiling? Ma'am, melting is required in order to change solid into liquid state. So in order to change, this is very important, in order to change 1 kg of solid into liquid at atmospheric pressure at its melting point, that energy is known as latent heat of energy, because you need some energy, you need that heat energy. So the heat energy which is converting 1 kg of solid into liquid, that heat energy is known as latent heat of fusion. Why fusion? Because when we convert solid into liquid, that is known as fusion. I hope it's clear.
Yes.
Yes, ma'am.
Okay, so quickly first you will write fusion. Okay, you'll just give like fusion and just write the definition. Change of solid states into liquid state is known as fusion. Okay, and then after that you will just write it down, then I'll just scroll down.
Done, ma'am.
Yes.
Yes, I'm done.
Okay, I hope everyone is done. Okay, now the next is next heading you will be giving latent heat of fusion. Okay, so ma'am, what is latent heat of fusion? The amount of heat energy that is required to change 1 kg of solid into liquid at atmospheric pressure and when at its melting point is known as latent heat of fusion. Okay,
Done, ma'am.
Finished, ma'am.
Yeah.
Okay. Who is not done? Justine and Jepa, you both are done.
Yes, ma'am.
Yes, ma'am.
Okay.
Done.
Okay, Justine, you are not done.
Ma'am, I'm done.
I think today's Justine energy is little bit low. Is it everything fine, Justine?
Yes, ma'am.
Okay. Okay, I'll just take no. I won't be pressurizing you people much. We are almost done. Okay, with today's topic. Okay. Now the question is, ma'am. For example, this is the particle of ice, and these are the particles of water. So, whether ice will have more energy or the particles of water, who will have more energy?
Water.
Who will tell me? Yeah, Justine. You are not audible, Justine. You want to give it a try?
Liquid.
Liquid? Okay, okay. Yeah. So basically, see, I was heating this. Okay. Now heat energy is being transferred to it, and that's why it became liquid. So basically, more energy will be with liquid. So that's why the particles you can see, because now I heated this I like ice. That's why the energy got transferred to this liquid one, right? So the particles in water, see, at 0 degrees Celsius have more energy as compared to particles in the ice at the same temperature. So you will get the question in exam hall like this: at 0 degrees Celsius, who will have, like, the particles of water or the particles of ice? Who will have more energy? So basically, at 0 degrees Celsius, the particles of water will have more energy. Why? Because of the latent heat of energy. Clear?
Yes, ma'am.
Yes.
So you will write like this. Just write it in box that at 0 degrees Celsius, water particles. Just a minute. Write it in box because this is very important. You get direct questions in exam hall. Okay. So you'll make a box and you'll write that at 0 degrees Celsius, in bracket write 273 K. Okay. At 0 degrees Celsius, water particles have more energy as compared to ice particles. Okay, at same temperature. So at 0 degrees Celsius, water particles have more energy as compared to particles or as compared to ice particles at the same temperature. I'm repeating. At 0 degrees Celsius, water particles have more energy as compared to ice particles at same temperature.
Finished, ma'am.
Done, ma'am.
Done.
Okay. Now back to our notes, the boring notes. Okay. So we already did this. Now basically, now you solid to liquid done. Now liquid to gas. Okay, this we are done. Now liquid to gas. Quickly we'll cover it. Now liquid to gas. So for example, this is a beaker and this is a liquid. Now you will heat it somewhere. What will happen? First of all, for example, this is the level of water. Level of water will come down and it will form vapors. Right? Clear? So basically, how you convert liquid to gas? Basically, you will heat them, you will boil them, right? Then only you can convert liquid to gases. Okay. So for example, the temperature of water was 15 degrees Celsius, normal. Then you are going to heat it. So it is going to increase 25, then 40, then 45. Just ignore this. You can just skip it. I just wrote it randomly. 40, then 45, 55, like this. It will keep on increasing, and somewhere it will reach 100 degrees Celsius. Okay. So at 100 degrees Celsius, basically what is the boiling point of water? It is 100 degrees Celsius. And if we'll convert it into Kelvin, it is 373 K. Okay. It is 373 K. Okay. So now what is boiling point? I hope it's clear. This portion is clear.
Yes, ma'am.
Okay. If I'll ask you what is the melting point of ice? So ma'am, 0 degrees Celsius. What is the boiling point of water? Ma'am, 100 degrees Celsius. Okay. Now basically you are going to boil it. Okay. So when we, now from here, when we supply heat energy to the water, particles start moving faster at a certain temperature point is reached. When the particles have enough energy to break the forces of attraction of each other, at the temperature, the liquids start changing into gases. So the temperature at which liquids start boiling at the atmospheric pressure is known as its boiling point. Clear?
Yes, ma'am.
Yes.
So how you are going to make the notes? Wait. First of all, you will write hashtag liquid to gas. Just leave 2 lines so that you don't get confused between solid and liquid to gas. In solid and liquid, we have done 2 things. First diagram, second melting point, third the latent heat. These are the part of the solid to liquid process. And now, if we'll do boiling point and the latent heat of vaporization, that will be part of liquid to gas. So you'll write liquid to gas and you'll draw the diagram like this. Just draw a beaker like this. Just draw beaker, 2 beaker like this. The level of water should be here, and here the level of water should be here. Okay, and just write 15. Then write, or you can just simply write 15, 25, and dash, 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 and 100 degrees Celsius. Okay. Just draw this, and definition we will be doing from this portion. And over 100 degrees Celsius, you will be writing BP, which is your boiling point. Done, students, diagram.
Yes, ma'am.
Yes, ma'am.
Now you will write boiling point. You'll do the draw. You'll write like that point, boiling point. So the temperature at which liquid starts boiling at atmospheric pressure is known as its boiling point. Okay. System. The temperature at which boiling, and then you will write boiling point of ice. Sorry, water. It was 100 degrees Celsius and some in Celsius or 373 K. Okay, I'll just explain you why it is 373 K and why not 362 K, whatever it is, don't worry. But right now you just have to learn it. It is either 100 degrees Celsius, if in terms of Celsius, in terms of Kelvin, it is 373 K. Okay, write it down. And then just one more thing, like similarly we did over here, we did latent heat of diffusion, right? So here we will do latent heat of vaporization. Just write this down and let me know.
Done, ma'am.
Yeah.
Everyone done? Yes? No?
Yes, ma'am.
Okay. Adil, Adil
Yeah.
done?
Yes.
Oh. Now basically the similar process. Now ma'am, what is first thing? Over there it was vaporization. Oh, it was fusion. Right? So now you will write vaporization. Vaporization, you can see. Vaporization. Just write vaporization. Okay, and write change of liquid state. Similar definition, change, but here over here you will write change of liquid state into gaseous state is known as vaporization. Clear? So you will write vaporization, then you will write change of liquid state into gaseous state, gaseous, gaseous state is known as vaporization. Done. Vaporization. Change of liquid state into gaseous state is known as vaporization.
Done, ma'am.
Done.
Okay, who is left? For Jeba and Jasleen, I'm
Done, ma'am.
confused because I cannot recognize the voice.
Done, ma'am.
Okay. Now, basically, similarly, what happens? For example, this is beaker, this is water. Okay, if you will boil it, when it will be vapor. So, if you will touch that vapor, the temperature will be same. It won't be very much hot. The temperature will be same as the temperature of liquid. Okay, so again, so where the heat is going, so heat is basically becoming hidden, it is hiding. So it is known as latent heat of vaporization. So you will write again, next point, hashtag latent heat of vaporization. And what, how you will write? The temperature at which no, you'll write like this: the amount of heat energy that is required to change. Okay, I'll just give you the definition. Amount of heat energy required to change 1 kg of liquid into gas at its boiling point is known as latent heat of vaporization. Clear?
Yes, ma'am. Done, ma'am.
Okay.
I'm done.
Jasleen?
Yes, done.
Now, the question is just the last concept. This is your homework. Okay. Earlier it was 0 degree, the 0 degree Celsius for ice and 0 degree Celsius for water. So the temperature, like the energy was more with water because it got converted. Now it is 100 because the boiling point is 100 degrees Celsius, right? So just tell me, 100 degrees Celsius water will have more energy or 100 degrees Celsius steam has more energy? So who will have more energy? Mm-hmm. Normal water or the steam water? Steam water is basically the boiled one which will be going up.
Steam water.
Steam water.
Yes. Why? So this is your homework. So similarly, like you already know the answer. So you will like this only. You will make a note. You will make a box. Tomorrow I'll ask you. Okay. So you will okay, where you wrote it? Yeah. So basically you will write particles in water at 100 degrees Celsius. Uh, you have two things: water particles and the steam water particles. Okay. So you whatever your answer is, basically yes, the energy will be more in steam water. Why? Because it got converted and the energy is transferred to that, right? So similarly, where like the box you made, so you will make the similar box and you will write whether water or the steam water, who has the who has more energy as compared to other one. Clear? So everything will be same, just you have to change, like at 100 degrees Celsius it will be, and here 373 K. Okay. Yes, you can do it on your own.
Yes, ma'am.
Okay, so tomorrow the very first thing will be everyone will state me this definition. Like this one, they will be stating me like what they have written. Okay.